Hello, my name is CallumWalters, student ID w1828868. In this video, I'll explain my applied AI coursework following Part A to E of the marking scheme. My chosen application domain is SMS spam filtering, and the goal of the project is simple: to automatically classify SMS messages as spam or ham using machine learning. I will briefly explain the background research, compare different AI techniques, walk through my implementation, evaluate the results, and finally discuss ethical and sustainable considerations. For Part A, I reviewed how artificial intelligence is used in SMS spam filtering. SMS spam filtering is important because spam messages can waste users' time, spread scams or phishing attempts, create security and privacy risks. Traditional rule-based systems struggle because spam constantly changes. For this reason, machine learning approaches are widely used. From the literature, common AI techniques in this area include naive Bayes, logistical regression, neural networks, more advanced natural language processing models. These techniques work by analyzing message text and learning patterns that are more common in spam than in legitimate messages. The research shows that this domain is well suited to machine learning because large labeled data sets are available. The task is clear binary classification problem. High accuracy can be achieved with efficient models. All sources are referenced in my notebook. In Part B, I compared 3 AI techniques that could be used for SMS spam filtering. Naive Bayes. Naive Bayes is a probability-based classifier. Its strengths are this: very fast, and it works well with text, but its weaknesses it also makes strong assumptions and word independence. The next one I did was logistic regression, which estimates the probability that a message is spam. Its strengths include it's efficient, accurate, and easy to interpret, but its weaknesses include less suited to highly complex relationships. And the third and final one I chose was neural networks. They learn complex patterns through layers of connected neurons. Strengths include can model nonlinear relationships and complex word patterns. Weaknesses is it requires more computation and tuning. All 3 techniques require text to be converted in numeral features and output is binary classification. I selected logistical regression because it proves a strong balance between performance, simplicity, and interpretability, which is ideal for this problem. For Part C, I implemented logistic regression using Python in a Jupyter notebook. I will explain how the system is structured, how the code works, and what the results show. A is high-level diagram. The system shows a clear machine learning pipeline. Load the SMS dataset, prepare the labels, convert text into numerical features, train the model, test it on unseen data, evaluate, visualize performance. This structure makes the implementation easy to follow and easy to assess. B was input data and pre-processing. The database contains the SMS message text, a labeled indication spam or ham. I embedded the entire database directly in a notebook, so the notebook is fully contained. Results can be reproduced without extra downloads. The assessor can easily run the code. I also included a link to the original dataset for transparency and proper referencing. The data is prepared by converting labels into binary values, splitting the data into training and testing sets. This ensures the model is tested fairly on unseen messages. C is how the code actually works. Machine learning models cannot work with raw text, so the messages are first converted into numbers. This is done by breaking messages into words, giving more importance to words that appear often in spam. Logistic regression, then, which words are most associated with spam, calculates a probability for each message, uses the probability to make a final decision. The model is trained on the training data and evaluated in test data. Results and visualization. The results include accuracy, showing overall correctness, precision and recall, which are important for spam detection, a confusion matrix showing correct and incorrect predictions. The results show that the most spam messages are correctly detected, legitimate messages are rarely misclassified, the model generalizes well to new data, the visualizations make it easy to understand performance and spot errors. Why this approach works well? This approach works well because the problem is clearly defined, the dataset is well labeled, logistic regression is efficient and reliable, the model is easy to interpret and deploy. For Part D, I evaluate the correctness and effectiveness of my implementation testing. I compared predicted labels with actual label using accuracy, precision, recall, and confusion matrix. These metrics confirm that the model behaves as expected. Evaluation, the result shows that the system performs reliably on unseen data, balances spam detection with low false positives. Strengths and limitations. Strengths include good accuracy, fast and efficient, and easy to understand. Limitations include depends on data training quality, limited understanding of message meaning, needs relevant means needs retraining as spam evolves. Overall, the system successfully meets the project goal. For Part E was the EDI and sustainability. For Part E, I considered the wider impact of this system, equality, diversity, and inclusion. Bias in the dataset could affect results. False positives may unfairly block messages. Transparency is important for trust. Sustainability. Logistic regression has low computation costs, minimal energy use compared to deep learning, and to reduce environmental impact, use efficient models, avoid unnecessary retraining. This makes the system practical and responsible. In conclusion, the project shows how machine learning can be effectively applied for SMS spam filtering. Thank you for watching. I've been CallumWalters.